Hey everybody, this is Larry. This is day 29th of the Leetcode Daily Challenge, and apparently there's a weekly challenge next, so stay tuned for that one as well. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, and and good luck on the contest later if you're doing it. What else? Hope everyone's having a great weekend. Uh, yeah, I mean, in the U.S. and New York, there are a lot of things going on, but progress is tough. Anyway, so today's problem is 460 LFU cache. LFU being least frequently used cache. Okay. These. Oh, okay. Oh, sorry. I was just thinking in my mind what's the difference between LFU and LRU, but LRU being least recently used. I guess I was like, I forgot what. Also, to be honest, I forgot what LRU stand for. So I was like, what is the R? And then when I remember, I'm like, oh yeah, of course it's different. But okay, let's take a look. Okay, so you have capacity, the capacity of the data structure. You have a get thing if it's in it, and then put. Okay, updates the value of the key if present, if or insert the key if it's not present. Okay, when the cache reaches its capacity, it should invalidate and remove the least frequently used key before inserting a new item. Okay. Um. Use counter is okay. I think I understand it. And obviously there is something about one, but let's at least to kind of at least initially deal with our understanding. Let's let's just do it naively. Is what I'm going to say, right? So basically, maybe self dot capacity is equal to capacity. We're going to put in this. Is it a set? No, a dictionary, right? So just something like this, and then maybe that's it for now. We probably need some other stuff, but oh, maybe a count, I guess. Also a dictionary. You can maybe it's a little bit weird to be alias. The initial thought that I have for least frequently used is maybe using a heap, but I think depending on how it's done, it's a little bit tricky. You can also maybe do it with a binary search tree type thing, but I mean you can also do it with a heap. But the problem is that the native heap thing doesn't have an update item thing, right? Because ideally, what you want is something that has a direct reference. But I mean, and you can implement a heap that way, but so that you can do an update on an existing key. And it actually, to be honest, is probably good practice to do it. But yeah, but it is just annoying to do. So and maybe on an interview you do it, but I don't know. But all right. So get would be just, if key is in self.text, then return otherwise return -1, I think. And then put is the interesting one, right? Least frequently used. That seems like I'm also just trying to understand this a little bit. Like if you remove something, do you? Oh, you also updated for get. Okay, but because I'm also curious whether like if you put something in and it's the newest item and you only used it once, do you before inserting a new item? Okay, but it still could get like some starvation thing, which is kind of weird, right? Meaning that you can remove the same item like or the same two items back and forth, and then I don't know, that's a little bit awkward, but maybe not. All right, but okay, so if this isn't key, then self.count of key will increment by 1, and here actually we want an int, so that the default is 0. Okay, and then put Okay, so let's just see how if length of self dot tick is equal to self dot capacity, then we invalidate one, right? The least frequently used. Oh, sorry, I'm rubbing my eye a bit. I think I have something in my eye after taking a shower or something. But okay, so here we ideally would kind of get the min item here. I guess in this case, you can just keep track of the min. Maybe. No, because after you remove it, oh, I'm trying to think. After you remove it, what happens, right? Because I was wondering, like, you keep track of the min until you need to remove it, but then there is another thing where when you increment, like I'm thinking about another thing where when you increment it, you kind of you know move it, kind of like move it in whatever, like almost like a bubble sort, bubble it up, like a rank list almost, right? As it updates. But that could also be wrong in that if you have all ones and then you update the two, it goes to the end, and then another two goes to the end, and in that case, the worst case will be O of n. So that's no bueno either. How do you do it? I mean, I can definitely. So one thing that I knew I wanted, or I kept in my back pocket, if you will, when I first read this prompt, and maybe I would have done that during a contest, to be honest, is this idea of a lazy heap. But I don't want to do it unless I feel like I don't know. And also I don't know that it is O of 1, to be honest. But am I missing something always? Linked list? No. Oh, I see. I think initially I was thinking about. I see. Okay. Because initially what I was thinking of is like a list. Let's just say we're keeping track of the counts, right? It's going to be, and then let's say you update this one to 2, and then you kind of move it back, and then you update, and because you're only incrementing, if you increment this to a 3, then you kind of just move this to the back, and move this 1 to a 2 or something like this, and then you keep on going, right? So you can maintain this list, but of course it's going to be too slow. But then now, or rather, I thought, and I was kind of alluding to this. This would be too slow because if we have all ones, if we update this one to a 2, then you have to move all, you have to kind of bubble past all the other ones, and then you have to keep doing it. But I think if we just kind of condense all the ones together, etc., then we can keep min in that way, right? Because and you can kind of even keep track of all the keys in you can even keep track of all the lists in like a linked list type thing, though maybe that is a little bit too intense. So we'll try that first. So then basically you have accounts that keep track of the counts, but basically what I want to say, buckets maybe, right? And then we can maybe do optimizations later, but yeah. So then we increment the count. So then now, well, self dot buckets of this thing. Oops. Actually, we should make it a set. We'll make it a. We should make a list. We'll make it a set, and then we remove key. We increment it, and then we add it. So then basically, we're moving it to the next number. Is the idea, right? Okay. And then now, when we put I mean, there's just more stuff to maintain with respect to the min, but like you can do self.min is equal to 0 or something like this, and when you get an item, then what am I doing? Right. Well, this will never. Oh, I see. Basically, what I want to do is something like if self.min is equal to this thing. Let's make this like some big number for now. Well, okay. So basically the two things, right? One is that if this is bigger than that, then we set self.min is equal to self.count of key. Basically, we're just updating the min. The other thing that we can do though is that if self.min is equal to this, before we remove it, well, maybe after we remove it, doesn't matter, we just do the count. And then this bucket is 0. Basically, this is just saying that the previous answer, well, we removed it, so we have to update the min to kind of support the newer thing, right? So then self.min, we incremented by 1 because that's what self.count added to here. Yeah, it's way yucky looking, I'm not gonna lie. Okay, and then here when we put, if it's at capacity, and this is a new key, right? Update the new. Okay, so if this is at capacity and key is not in self.dict, right? I'm just writing this down. I mean, it's not really a big deal per se, or like, you know, we have to do some other stuff, but that's basically it. We want to do self.min is equal to 1 at some point because this is the new item, right? So then obviously the count is going to be 1. Let's put that as well, right? So yeah, and then now we have to erect something. Basically, the self.min. This part is probably the part that I'm least confident about, but yeah. Oops. So basically, we have to remove something from here, but I think there was another second type breaking rule, the least recently used. Screw you. Least recently used. I mean, okay, you can just do another thing. Buckets. This is terrible. Not gonna lie. I'm curious how past Larry did it, but yeah, I mean, you know, this is just keeping track of this, right? And then now, no, because then you have to remove it, and then now, how do I keep track? Least recently used. This is just so annoying because basically now we want buckets to be because if it's a set, then you can remove it quickly, but if we have both, then you know. Because basically if it's a tile on the same bucket, we want to invalidate the one that is least recently used. What is the best way to do that? I mean, you can do a lazy thing, I guess, lazy deletion on the buckets by recency, but I feel like this is like really pushing it in terms of like there's a lot of laziness in here. Because basically now we do something like buckets by recency dot append key, right? Because now this is the last thing on self.count of key, and we should delete it from here, but we're not, because if we delete it now, it is going to be O of n if we kind of keep doing it every time. But if we do a lazy delete, then it is going to be O of 1 amortized. I mean, which is true. Did I write sockets? How did that happen? But sorry, friends. Which is, you know, both fine and also a little bit sad. Okay, so then basically we want to pop the last thing here. Yeah, so let's just say previous key maybe is equal to this, right? And then while p key is not in self dot, oh, this is buckets by recency. So if it's not in buckets, that means that it got moved to the next one. So then dot buckets I have to check some stuff too. I have to check that this is yeah, basically while self dot buckets by recency of self dot min, while this length is equal to 0, we increment the min, because by definition we should be able to get there because we have read capacity, and that's the capacity is 0. Man, why would you be doing that? What does that even mean with capacity is 0? Like, can you insert stuff? It doesn't actually say, but I guess we'll have to figure it out. This is such a mess. All right. Oh, there should be buckets, I think. Okay, and then now okay, so it gets the last previous key. If it's not in buckets, then well, then p key is equal to the next one. No, this should be correct that this will differentiate, because there is a invariant which they should match. Anyway, and then now yeah, given that we removed that pop, then now we remove it from buckets, and I think we popped it from the last one, so we should be okay there. And then we kind of just add it in, and I think here we can actually, doesn't have to be, this is just part of the erection logic, so that should be okay. This is returning, oh no, this is returning none. Let me just run it real quick. Did I forget a comma? Probably. Where is this? No. You are also right. Thanks. Okay. What does that mean? So into the count, we should put a key, right? Did I not add it? No, we should add it. But if this is 0, no, I mean, which one? What is it erroring on? This is, can be an, okay. There's one. Okay, so this is empty so far. What is the input? So put and then put and then get, right? So why is there nothing in here? Ow. No, that part is right, but I didn't, for some reason, I didn't put the bucket stuff. So, okay, that makes sense. Let's see. I just didn't update it to the bucket stuff. So then, no, wait, this isn't true. This is only true if key is not in this thing. So I'm being bad. Okay, fine. And then I also need to do self buckets of one dot append key or add key in this one. And then self dot buckets of one buckets by recency. This is so much work. Dot add key or append key in this one, right? And then now, yeah, let's just say we return. Otherwise, I guess we just do a lot of things that we do here, which kind of makes it a little bit awkward that we have to do it twice. Right. I do not usually advocate copy and pasting, but I'm just kind of seeing if this works for now. Yeah, so this is just incrementing things, so I think that should be okay. You just need okay, self dot of key is equal to value, and then all this stuff is just for incrementing things. Maybe I haven't put in a function, helper function. Here it's still no bueno. Because before it was 0, is it? Or it could be 0? No. Okay, so the first time this would be 0, but the first, oh no, I see, because I thought that it would be here, but yeah, okay, fine. But this is okay. I guess I can actually remove this part, and then yeah, they'll fall through. I think that's maybe slightly more complicated or tougher to understand, to be honest. But all right. So now the key hours too. Sorry, friends. This is not a easy problem, or just annoying to do. At least the way that I'm doing it. Okay, so you want to get a 2. The key is 2. And then the buckets to count. 2 is not in there. What? We definitely have a 2 in here. Yeah, this just kind of disappeared on this buckets thing, didn't it? Because 1, 2, and then you add a 1, so then 2 is a twice. But then did I make a mistake here somewhere where I just kind of set the list or something? Like, what happened to the 2? Or maybe we removed it from somewhere. Why is this output so weird? Because it's not like output, oh, because it doesn't get to here, but that's, I see. Okay. This is yikes. Okay, so it goes to 1 and 2. It does a get. So then now this get for this 2. So doing a get for the 1, it works well, and then it adds a 3, right? And then it does this thing. So adding the 3, it does. Wait, what's the capacity? I put 2. Oh, I see. So then it removes the 2. Oh, I didn't actually do the deletion, didn't I? So I removed it from here, but I didn't keep. That's just me mistake then. Okay, so basically now that we have this, we have to remove it. Del self.dict of p key, del self.count of p key, and then yeah, I think that's fine. Maybe it's more fine. I don't know if it's okay. I mean that's okay. I mean like we can work with things. I didn't realize the capacity was 2. That's why I was like, where did the 2 go? But okay, so after doing a get on 3, what is it failing on? The second, well, 2 things really. So I'm getting the 1. It should be the least recently used. No, I think I removed the recently used instead of the least recently used. So that is just silly on my part. I can't read correctly. So yeah. So instead of pop, it'll be pop left. Where is it? Where are you? Okay. Hopefully that resolves it, and it does, because reading is fundamental, and I didn't know how to do it. Okay. I mean, I'm gonna hit submit, but I'm not gonna lie. This is just due to laziness. I'm not that confident about this one. There's just a lot of silliness that could happen, and maybe even TLE, to be honest. Okay. Oh, that is the one case that I should have tested though, because we talked about it very slightly with respect to the 0. So, okay, fine. Because I think, yeah. Okay, let's put it in here. That was the thing that I meant to do, but I forget. I don't know what they want us to do for 0. I think that was the thing, right? Like, is it just return -1? Like, do you actually put in something? Because the phrasing is that you still insert a new item, but that doesn't even make sense, right? This is such a, I mean, that's such a silly input. Like, what does it even test really? Okay, fine. Like, maybe that. I mean, that's just silly. Okay, fine. Let's try again. Oh, that actually worked. Wow, the last time I did it, I got 5 wrong answers. So we made an improvement, and one that I kind of was talking about, but how did I do it last time? I did it with a linked list and a frequency hash. What the? I guess that's kind of what I did with the queue, maybe. But yeah, I mean, I don't know. I don't feel that bad. I just didn't know what they wanted. Maybe I should have ran it, but yeah. So everything that we do is constant time on average. You can think about it as, yeah. I mean, the 2 operations, get and put. Sorry, charging my phone for a second. Because it just died. Let's just say maybe I'll do a increment, self key, and then that's just this part really. Right, that will make it maybe slightly more readable, and I think I have it here as well. Is that part? No, I guess that part's right too. Right, wanted to submit it again. All right, so that looks good. Should have cleaned it up a little bit first, but that's fine. So we'll go with the increment independently. That's how we, the analysis is a little bit straightforward. But assuming this is O of 1, then obviously get is O of 1. this part is not super clear why this is all of one amortized, but basically the idea is that if you for every time you need to increment self.min, it is just to catch up to the capacity that it had before, or like some previous addition that it had before. So you can kind of think about it as adding it, catching up later on that addition versus as you're doing it, kind of maybe. Yeah. And here, of course, for every put or get, and we will put one more item in buckets by recency. So that means that every request you put one new thing in there, so you can remove them one at a time as well, more than one at a time. But on average, you can only add and remove one item in this lookup list. So that's why this is all of one as well, amortized again, and the rest is just more straightforward all of one. This is just setting things up, but yeah. And then this part, right? I mean, let's just say lookup tables sets are all of one. Then this is 2 hashes, so that's all of one. This is just all of one as well. Yeah. And again, as we said, we only add. Well, this thing we removed it, the previous one. So this is just moving one list to another. And then here, as we said earlier, you're only gonna remove one. So yeah, this is a very annoying problem. Let me know what you think. Let me know how you did it. Show me your code. That's what I have with this one though. So as I said, we're gonna do the premium question next, the weekly premium question next. So yeah, stay tuned for that. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.